All right, this recording is for section 4.1, quadratic functions. There's 24 questions in the homework, and there's also an introduction video as normal, and we have the first question. Now, the first question is just really looking at the quadratic in respect to translations and what moves the function. Now, it also gets into the point of where the vertex is. So let's take a look at this function. So what is changing, of course. Now, so we look at this, and I'm going to write it a little differently. I'm going to write it the way I did for translations of functions. All right, this should look familiar to you from another lesson from the last chapter. Now, this is what we call well, there's different ways it's called in different texts. Like I call this the vertex form of a quadratic. And the reason why is because the vertex is revealed right in these two numbers, where this is the horizontal change and it's the vertical change. So if we're looking at just these two components, this is horizontally changing it like so. If it's positive, it moves it to the left. Always go like this. Always put an arrow structure. And I say if it's positive, it moves it to the left, and if it's negative, it moves it to the right. I mean, it's just like, okay, so here in this problem, it's a positive 2, so that means it's going to go to the left 2 units, and it's going to go down 5 units. So this one hangs true to be what it is. If it's positive, it goes up, and if it's negative, it goes down, by the way. Okay. So that's, and then I think to myself, well, if I was doing this and I wasn't that confident about what I was doing, then I've always had my trusted calculator to support too. So if I punch this into my calculator, I'm only going to do one, and you can do the rest on your calculator. But I'm going to just show you the answer, but I wanted to give you the resources. So you open parenthesis x plus 2, and then hit square button. That allows you to just get the square right away, and then minus 5, and then graph it. All right. So this is just one of the 4 graphs that are provided there. So they want you to go ahead and graph them all, and the one I just did for you was this one. Okay. Now you should notice that the vertex is at -2, -5. Notice that it's right there. All right. -2, -5, and that's true for this one as well, right? So then if it's -2, +5, then that would be up here, right? The vertex is up there, because that would be +2, +5. All right, and then of course this one then being that this one's negative, this would be -2, +5, that would be this one. And then this one's +2, -5 would be this one. All right, so it looks pretty cool when they're all drawn like that. All right, interesting formations. All right, and then you wonder why some graphics are presented in certain imagery, and it's because of math. I mean, it really is. People undermine the power of mathematical equations because they don't understand them. But it's, you play with them enough, and you see them. You see these things, especially when you're getting parametric uh, functions and stuff like that. That gets interesting when you get into trigonometry and stuff like that. So you get exposure. So I'm going to let you go ahead and be able to graph these. I mean, this is negative. This is when you reflect over the x-axis. So you're going to have reflection going on here. They're trying to show you the difference between this and this. And so again, you have your trusted calculator, you have your y equals, and you can put it in. So it's kind of a waste of time me doing that for you. So you have the ability to do that, okay? I'll let you figure it out. Now here it says find the vertex, the y-intercept, the x-intercept of the parabola that is defined by the following quadratic function. Now, I've already mentioned to you, all you do is take the opposite of the H, all right? So you basically just take and figure it out that your HK is your vertex, all right? So then you're going to take the opposite, it's going to be 5, -1, all right? So that's your vertex. Now your y-intercept is always going to be when x equals 0. So if this x equals 0, that goes away. It'd be -5 times -5 is 25, -1 is 24. So then it'd be 0, 24. The x-intercept is when y equals 0, so you just let the f of x equals 0. And if you can't do that mentally, like I've been verbalizing, simply just write it down. I mean, I don't think that this is too much to ask of you. If you can't do it mentally, move this over to the other side. It becomes this. You square root both sides. And then, of course, you add 5 to both sides. So it becomes 5 plus 1, and then that's 6. And then 5 minus 1 becomes 4. So then you have 2 x-intercepts. Okay? So here we have 4, 0, and then 6, 0. Now they want you to have it in form of writing as a point. Okay, just make sure you take note of that, all right? All right, so I'll let you have this one. All right, same idea. Find a vertex, find the y-intercept, find the x-intercept. Same thing goes for this. And now, wait a second. Okay, yeah, that one. I have to explain something here. When it comes down to then the quadratic, so I told you this was in vertex form because it's so easy, but sometimes it's called standard form, and then there's general form and stuff like that. So standard form, general form, and vertex form. Standard form and general form are the two that are typically associated with each other. Whereas the general form of a quadratic equation is ax squared plus bx plus c equals 0. Now we're going to go ahead and say that the way we find the vertex is we take the opposite of b, all right, divided by 2a, all right? So this is part of the formula for the quadratic equation. And what we do is that's finding the axis of symmetry, okay, as well as finding the x value of our vertex. And then what we do is we insert that equation back into the equation itself to find the vertex. So the value of b in this case, okay, is going to be -42. All right. So we go ahead and put positive 42 in there, divided by -3 times a, which is going to be -6. All right. And then divide it out if you can. So you get -7 for the value of the x value of the vertex. Now what we do is insert it into the equation and then get back the y. Now you can use a calculator. There's no shame in that. All right. So all you got to do is go ahead and do -3 times. I'd like to go ahead and do parentheses, but -7 squared, and then -42 times -7. All right, and then we have -159. And that gives us -12. So our coordinate point is -7, -12. And that we can just use our calculators to do all that. All right, -7, -12. So that was a very important formula that I had to share with you. And then inserting it back into the equation. And a lot of this, students, is using this calculator. I mean, because why do all the work? Let the calculator do its job. Now, one thing that's nice about this form, when it's ever in this form, is that the y-intercept, this is the y-intercept. It's identified right there. And we can go ahead and say it's -159, boom, done. So 0, -159. All right. Now, if you go ahead, all right, and now the x-intercept. Now, here is what I want to show you. Now, you go ahead and plug it into the calculator. Let's just plug this one in. -3x squared minus 42x minus 159. We plug that in and we graph that. Okay. Now this graph is not showing up. Okay. So what we might want to do is zoom out and see where, oh, there it is. Okay. It's showing up now. All right. Now the x-intercepts, okay, they don't exist. There is no x-intercepts. So that would be D and E. Now, are they imaginary? Yes, but they're not going to be, there's no x-intercepts. There's imaginary zeros, but not x-intercepts. So you can find that out without much work. All right. So it's really important that you get familiar with the use of your calculator, okay? So you can be able to use it efficiently. Okay. So I'll let you now have control over this one, number 6. All right. Now, some properties, quadratics. Now, vertical orientation is basically asking you whether the thing is going up, the parabola, or whether it's going down. Okay. Now, whenever A is negative, in which case this is negative, all right, it's going to be when A is equal to negative, then it's going to open down. Whenever A is equal to a positive, then it's going to open up. All right. So this one's what we call a downward parabola. Now, again, I've explained that the vertex, the process for finding the vertex does not change. All right, you're going to go ahead and do what I've already explained right here. All right, so it'd be 14 divided by -2, which is 7, and then insert 7 back into the equation. You're going to go ahead and get -7, 1. Okay. So yeah, because it's 14 divided by -2 is -7. So then you insert it back in the equation, you get 1. Okay. Now, because the value is a downward bound parabola, all right, then that is a maximum. The vertex is a maximum because it's top of a hill. So it's going to be a maximum for that reason. All right. So I'm going to put answers here. Maximum, or downward maximum. All right. Now determine the y-intercept. Now the y-intercept is at -4, so it's going to be 0, -48. I mean, I'd say -4, but it's -48. All right. Determine the x-intercepts. Again, you use your calculator. Nothing's changing here on how that works. All right. Determine the x-intercepts. Okay. Determine the axis of symmetry. Right there. All right. Axis of symmetry is the same value system as your x component of your vertex. Always the same. Watch. Look at. Here's the x value of your vertex. Axis of symmetry. X equals the same exact value. Okay. Make sure You remember that because it's the easy way of, don't make yourself have to do more work. Don't do this formula again. You've already done it. All right. Now, because of the power of technology and that you're graphing it, you should be able to take and do that and be able to also take and determine what the graph looks like based off of those same priorities or parameters. Now determine the domain. Domain for all quadratics, unless it's not a function, is always infinity to negative infinity to positive infinity. And then the range, if it's a downward bound parabola, then it would be negative infinity to all the way up to where it stops going up. So then this particular one is going to be like this. So it's negative infinity all the way to when it stops going up is at 1. So it's going to be negative infinity to 1 inclusive. So that's the answer for that. And I say purposefully with the inclusive because that's important that you include that value because it goes all the way up there and stops. Nice thing about finding the x-intercepts is because it helps you when graphing. Okay, so that I mean, I can't stress it enough, but the calculator will do the graphing for you as well. All right, and you have these different properties of your quadratic, and we're going over all the different properties of the quadratic. Now, you again use your calculator, plug it in, and figure out what it looks like, and then you can go ahead and answer this. But you should understand that this is an upward bound parabola. The vertex is that negative b over 2a, and then so you go ahead and insert it back into the equation, and you get 8, negative 3. It's going to be a minimum, and then it's going to be where you have your y-intercept is going to be 189, so it's going to be 0, 189. And then the x-intercepts is when you cross over the x-axis, and that you can determine by putting it into the calculator. Your axis symmetry is going to be the same exact value as your x value of your vertex, so x equals 8. You look at your graphing calculator to determine what it looks like as far as the graph. All right, and then you can see that the domain is always going to be negative infinity to positive infinity. When it's upward bound, it's going to be from the point, which is negative 3, all the way to infinity, so inclusive. Negative 3 to infinity. So that's how you answer these component parts, okay? They're just breaking it all down. And sometimes they don't give you the C value, all right? So there's, again, the calculator, all right? I'll let you have a whack at that. I'm not going to keep on harping it. Some of this is, easier than others. Like this is the vertex one already. The A value is still positive, so it's up. And so there's just common systems of answers that you can figure out by just looking at it on the graphic calculator as well. Okay? All right, nothing's changing here. I'm going to just move on. It's the same kind of concept. Now the function has, and then what do they look like? Absolute minimum. So they're giving you different parameters of the way that the system works. You have absolute minimum, absolute maximum. This one's a positive, so that's what that means when it's upward bound parabola, that it's a minimum, and I talked about that already. All right, and where does it occur? All right, so it's negative 16, and where does it occur is at 3. So what they're doing is giving you the vertex. They're determining the vertex. Okay. This is the input. That's the output. And then you go ahead and state the domain and range. Okay. So they're breaking down the components of the parabola again. Nothing's just different angle about how to look at the quadratic. Okay. Now, you got the generic quadratic. All right. So this is what they're calling generic. All right. And I called it the general. I mean, general and generic are the same thing. All right. determine, and so then it says the vertex is such, okay? When it's such, the vertex is such, all right? Now, it's negative infinity, positive infinity, always, okay? Now, it's saying that A is less than 0. So if A is less than 0, it's negative, therefore it's opening down, all right? And so you come in from negative infinity all the way up to wherever the Y value is, all right? And so the graph of F parabola opens upward. So we're looking at a minimum here. So then it's still going to be negative infinity, positive infinity. The range is going to go from -10 to positive infinity. Pretty easy to do these. All right. Find the dimensions. Okay, now I want to go over this one a little bit. All right, now it's talking about maximum area. I'm just going to let you know that a square is the maximum area for a rectangle. A square. I mean, it doesn't say square here, but it is in fact a square. I just can't express to you how everything's about square. But here it says find the dimensions of rectangle with a perimeter of 16. So the formula for perimeter, by the way, is 2L plus 2W, right? Equals 1680. All right. Now, the maximum area is length times width, right? Equals area. Now they're trying to maximize this value system. Now, what we're trying to do then is go ahead and think about it in terms of finding the parabola. All right, like, so we're looking at maximum, like, so here it looks like something like this. So we're going to need the negative b over 2a, okay, to find where that happens, okay? And then we can go ahead and determine what the value systems are, all right? So if we take a look at this, okay, and by the way, watch this. I go ahead and show you the answers real quick to show you that I said to you that we're looking for the maximum length and maximum width, but it's in order for it to have the maximum area, it has to be a square. So how to get to the 420? Okay. Now, since we know that this is the value system we have here, we can go ahead and just isolate for one of these variables here. Either one, it doesn't make a difference. Okay. And then we could get it solved or put back in to this equation here. All right. And then it turns into a quadratic because you're multiplying. So watch. So if we go ahead and do this, we get 1680 minus 2w. And then divide both sides by 2, we'll get L is equal to 1680. Whoops, let's go ahead and do 1680 divided by 2, right? I don't want to have to do that. So let's do that. 1680 divided by 2. And then we have W, right? Because I'm dividing everything by 2. And then I have W, see, because all I did was replace this L with the value of L equals 1680 divided by 2, negative 2W divided by 2. And then I have the W here equals the maximum area. Okay, and then we could go ahead and put max. All right, we can go ahead and say max, but we don't care. We don't really care about this. All right, we don't even know what that is, but we just know that this right here will give us the maximum. That's the whole point of this. That's what this exercise is about. So people start being threatened by this. Who cares? So negative W squared, all right, and then you have plus 840 W. So what we do is we take our formula now, negative b over 2a. All right. So we're going to take the opposite of 840. All right. So that's opposite, excuse me. Then we have we have -1 for a, so it's going to be -2. And then we're going to do negative divided by negative positive, and then 840 divided by 2 is going to give us 420. Hey, wait a second. There's the answer. And because we want to maximize it, all right, that is the value of the W. We go ahead and take and understand that because it's a square, in order to be maximized, all right, we're just going to go ahead and put it as 420, 420. So what is the maximum area? You just take 420 times 420 and gives you the answer of 176,400. That, to me, is how the easiest way you can approach this. All right. So I just helped you with that one. That one was a big one. Now NASA is launching this rocket, and here's the function. The rocket splashes down after blank. So splashing down means it's in the water again. So it's when the output is equal to 0. Okay. Anyway, I know some of you are really troubled by word problems, but think about it. A rocket goes up, a rocket comes down. Okay. So thing is that the darn rocket is already up in the ground. It's on a pad, right, at 120 something feet, and it's, or meters, it should, yeah, meters. Okay. And it comes down and hits the water. Okay. Where then x, you're looking for where the x is equal to 0. So the output is equal to 0, or input equals 0. Okay. So what we're finding out, like where the x-axis output is equal to 0, then we're going to be going ahead and just using our calculators. All right. Plug it in and see where it is. Now the thing is that it's right here. It says 11.544 seconds. Okay. So that's time. How long does it take it to go? All right. At elevation 0. So you can go ahead and use a couple different methods, but you can go ahead and use the quadratic formula if you wish. All right. So you got to take for how you want to approach it. I don't want to sit here and do everything for you, but I would take and do it by the quadratic formula myself, just because it's such a unique value system. So if I was to take the quadratic, I would just punch it in my calculator. And I'm going to do it right now on my calculator. All right. Now, let me see. So I have negative. Okay, yeah, here we go. Negative 4.9. Oh yeah. Let me do it by the quadratic. All right. Let me go ahead and punch in. All right. So I have negative 46. Let me plus or minus, and it's 46 squared. That's minus. Let's see. No, it's actually going to be plus, actually. All right, so that 4.9 times 4 times 122. And then we're looking at 2 times 4.9. All right. Now, when we're looking at this, right? When we're looking at this, we want to go ahead and consider the fact that we don't care about negative side. We don't care about the negative side because that's going to give us on this side of the equation. And who cares? All we care about is this side, right? So with this equation, all I'm going to do is consider the positive value. That's all I'm going to consider. All right. So that's what I mean by, like, now I'm going to put it in my calculator. So I'm going to take and do alpha this, and I'm going to do negative 46 plus the square root of plus 239 1.2 all divided by 9.8. And here we have our answer. Now this is how long, all right, this is how long the, wait a second. The rocket splats down after blank seconds. So that's the X value should have been that. What did I do something? No. All right, so I'm getting something that's a little goofy. So I'm going to go ahead and take a look at this one. I'm not getting an answer. All right, assuming the rocket splashes down after blank seconds. So we're looking at when it hits 0, and that's the answer we're looking for. Oh, maybe that's what it is. This is negative, but that shouldn't make a difference. Maybe it does. Hold on. No, okay, so it's negative 2 point. That would be on that side. That would be on that side. So you're telling me that? I'm wondering, because it's a inverted parabola. I'm going to go ahead and put it in the other way. I have to now go ahead and test my theory here, because maybe my theory is wrong. My theory was wrong. So we need to have the other side, because it's inverted. I needed the negative side of it. I don't want negative value, by the way. So that kind of threw everything off. So it is, I did it right. It's just that I made 2 false assumptions, and the fact that I made it where I thought it was right side, left side, but it's inverted. So that made a difference. So anyway, I want to make sure that I'm using my quadratic equation correctly. And then because I was negative on my one value system of output, it kind of threw me off. So I went ahead and changed directions here. Just notice this. Okay. Notice how I made a mistake here. The 9.8 was supposed to be negative because it's negative 4.9 times 2. So that, and then I came up with a negative value output, and I didn't like that. That wasn't good. All right, because I don't want to deal with negative time. So I went ahead and evaluated at the negative value. So this is the plus, and this is the negative of this formula. Remember, it goes plus or minus. So if one's coming out as negative output, I don't want it. I throw it away because I'm talking about seconds. And here's the answer we're looking for. All right. So use a quadratic. That's my point. Because if you punch this in your graphing calculator, you're going to get frustrated because it's not going to come out so easily. I'm going to go ahead and drop it in, and I'm going to show you. Negative 4.9. And then x squared, doesn't matter about the variable. 46t plus 122. Now, when you go ahead and graph this guy, right? Look at it. You have that negative and you have the positive. All right. Oh, there you go. Sorry, it's so blurry to you. All right, you have the negative and you have the positive. So I just put it in here, okay? So then again, the graph. Now we want to zoom in. We don't want that negative one. We want the positive one. So if I go ahead and hit zoom box, Z box, I'm going to focus in on just this area right here. So I'm going to hit enter and I'm going to come down. All right, I don't need to come over so far. Hit enter. Now I have a value system that's right here. I have no idea what this value is. Now, if you can see, based off of this, I'm getting pretty darn close. Look at that number system. All right. So what I can do is I can hit second trace, which is calculate for a 0. And I need to go ahead and be, see this value system? I need to be left and right. How do I get you to see it? Man, it's hard to see it. So I need to be left and right of that. All right. So see how I'm now bouncing into it? All right. So I want to be above it, hit enter. And I want to be below it, hit enter. And then look at that. Now I can get the value system at 11.544. So darn it, the calculator can assist you without the quadratic, by the way. So I just proved that to you. So I did it 2 different ways. Okay. So how many seconds after launching does the rocket reach its peak height? So again, that's negative b over 2a. Negative b over 2a. So it's basically this right here. All right. And you can just take your calculator and do that. Take negative 40, well, negative divided by negative positive. So 46 divided by 9.8. And so we get our answer. All right. And it does say to round off to 3 decimal places. How high above the sea level does the rocket reach at its peak? Now, I want to show you how to use your graphing calculator a little bit. Now, we want to talk about peaks and stuff. So let me do zoom 6, zoom standard. It's flying off the page, okay? And it's, you can't see it because remember, this is only by a 10 by 10, so it's going to be 11, so it's over here somewhere. So if we go ahead and do zoom 3 out, all right, we get that. Now what we could do, all right, watch this. I can go ahead and hit second, and then I want to hit calculate, and I want to hit maximum, right? Because this is why we learn about maximum, minimums, and stuff. So maximum, and then I'm going to go ahead and pick somewhere that is going to be to the left. So I'm going to hit enter. And then I'm going to go ahead and pick somewhere that's going to be to the right of the peak. And see, so what I'm doing is measuring that, and I hit enter. And then now, see, I really want you to get used to that, by the way. And if you have to go ahead and review what I did, then do, by all means, do it. And so I get the value system right here, and round it off to the nearest 3 decimal places. I get 959. So look at it, 229,959. So that was a lot easier using a graphical calculator, wasn't it? So maybe disregard using the graph or using the quadratic and such. Use a graphical calculator. It's going to make it a heck of a lot easier. I mean, I'm kind of laughing because I couldn't imagine making it easier than that by just using a graphical calculator. So if you can't understand what I'm doing with the maximum, like finding the maximum, you're going to need to maybe YouTube it, just say finding the maximum of a curve or a parabola, perhaps. That, and then YouTube it, it'll help you. But again, it's second trace maximum for a curve that's inverted. And then once you hit that, you got to go left and right of this. So if this is my maximum right here, okay? This is my maximum, which I have no idea what it is. Then I got to be left of it and right of it. Determine, it doesn't matter how far left or right I am of it. All right. But I have to be left and right. And that's what it's asking me to do right now. Determine what the left bound is. So I need to be somewhere over, over here. I don't know. And that's a big old whopping question mark. It doesn't matter where you are. And then I got to go to right. I got to go somewhere, and that doesn't matter where you are. As long as you're left and right of this maximum area, because it's calculating between the two parameters you set and determining what the highest point is. All right, what the maximum output is. All right, so think about it in terms of that. That was a great question for me to go over, and I appreciate that you were patient with me and me going over it, because it's something that I needed to explain in detail. And I took two different approaches. This one wasn't the most ideal, was it? Because I almost made a mistake in my analysis of it, because it's easy to make mistakes with signs and misinterpretation of thought about where you are on the parabola. All right, so be careful about it. So this one says the height in feet throwing the ball. How high is the ball? How high is the ball when it leaves the child's hand 3 feet off the ground? Because that's the point. And then how far from the child does the ball reach its maximum height? So you got to do this whole concept of negative b over 2a, and then you got to calculate for it. I would use a quadratic. I would go ahead and do this again. I mean, since you're getting used to it, let's go ahead and plug it in. By the way, to do fractions, again, it's alpha y equals enter, and allows you to put in fractions. So I get that, and then I get plus 4x, and then plus 3, and then I graph it. All right, now, oh, it looks, it's a line. It means, because it's a line, it means I forgot the squared. So I need to go back here. As a matter of fact, I forgot the entire x squared. So I need to put that in. So to insert something, hit second, delete, inserts, put x squared. All right, now I graph it, and I get my parabola. Okay, so now I can see the curve. Now, because of the way this is working, right, I want to go ahead, and I see that it's very far away. It's how far from the child does the ball reach its maximum height. So we're about this distance. So we want to go ahead and do zoom, zoom out. Whoops, zoom out is 3. Okay, now I can see it. Okay, now I want to go ahead and calculate for the maximum height again. So I hit second trace, which is calculate, and I want to hit maximum. I want to be left of the highest point, be right of the highest point, anywhere, it doesn't matter, and then hit enter. I see here how far away is 32. All right, so then what is the maximum height of the ball? It's 67. It's right there. So important that you are able to see how fast that is, because that's going to give you a really easy way of calculating for these numbers that we're looking for here. How far from the child does the ball strike the ground? So I'm looking for, this is how you calculate that. Hit second trace 0, and it wants to be left and right. We want to know where it is that it strikes that ground at that point. So I hit enter, 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 and that is going to be the answer we're looking for, which is 64. All right, and then of course it wants us to calculate to the nearest 3 decimal places, so it's asking us to go ahead and to provide those 3 decimal places. Not a big deal. But wow, was that awesome using the graphing calculator? I figured it out within kind of, seconds compared to doing it by hand. Okay, so take it for what it's worth. All right. Now, we are looking at a couple more word problems, but I mean, I'm getting a little late. I'm going to try to let you be challenged by doing this problem right here. All right, this one's going to challenge you, and I know that because I've done a little exercise with students, and this one's I've done this one with you with a little bit about the perimeter and stuff like that. So I'm going to let you have this one, and of course, if you can't figure it out and you're really upset about it, I'll go for it. But I'm trying to challenge students to go ahead and use what I did here to figure out this one. Okay. So, and you got to recall that it's now rectangle, all right, or well, it looks like it, right? So, and also one side isn't covered, so I'll let you do that one. All right, so that concludes this lesson right here. All right, and I'll pick up on 4.2 in just in the next video.